So now we are going to discuss about reduction potential values. So reduction potential of D block elements. So actually the reduction potential values are depending, so that is inversely proportion of the sum of, that is ionization potential, sublimation energy, next hydration energy. So it is depending on reduction potential value depending on these three. So inversely proportion to the sum of the ionization potential, sublimation energy and hydration energy. Suppose here we are seeing generally the D block elements are showing +2 oxidation state. So that's why M +2 by M reduction potential values. If we see means it is observed like suppose you take 0, this is a negative, this is a positive. So suppose you take a 3D series, so that values are observed vanadium, next chromium, so copper it is going, next zinc. So in 3D series only copper has a positive reduction potentials, remaining all are negative. See here the value reduction potential value negative means that is a readily loses electrons. Readily loses electrons, one point, and that cation only stable. That cation is stable. See, suppose you take chromium, chromium +2. So chromium +2 reduction potential value negative. So chromium +2 is stable. So next you take zinc, Zn +2 reduction potential is negative. So that's why zinc +2 and chromium +2 are stable. So they readily loses electrons. So that's why these two are what? Reducing agents. Negative value is there means direct you tell that is reducing agent. Suppose the same copper you take. So copper reduction potential value is positive. So that means copper +2 is unstable. So that means what? The copper is acting as reducing agent. Not reducing. It is what? Oxidizing agent. So copper +2 is unstable. So that's why copper +2 is readily taking electrons. So that's why it is acting as oxidizing agent. So always you remember reduction potential down means reducing agent, above means positive. That is oxidizing agents. Next here second M +3 by M +2 that we are taken means the graph will be reduction potential graph. So positive, 0, negative. So that is scandium, titanium, vanadium, chromium. Chromium is going down. Next scativechroma. So manganese. So that is scativechroma. Next feconi. So this is observed like this. So already we discussed what is that chromium. Chromium +3 is converted into chromium +2 reduction potential. So you are getting what? Negative value. Negative value means chromium +3 is stable and it is acting as a reducing agent. So already previous also we discussed the same thing. Next, who are above? Manganese. So Mn +3 become as Mn +2. Reduction potential value is positive. So that means what? Mn +3 is unstable. So acting as what? Oxidizing agent. Same thing, you can take cobalt. Cobalt +3 is converted into cobalt +2. Reduction potential is positive. So positive means CO plus 3 is unstable. And this is what? Oxidizing agent. So the value who had the positive, that is oxidizing agent, negative, that is a reducing agent. So always remember, suppose the given the things which has a highest negative means that is the highest stable compared to all ions. Next, the D block elements, general compounds. Suppose general compounds means you take halides. So halides, suppose you take iron, FeCl2, FeCl3. So means plus 2 plus 3. If you know the oxidation state, according to that you can easily write that. Suppose chromium. So chromium is 6th group, maximum is 6. So it is showing plus 2, plus 3, plus 4, plus 6. Suppose manganese is showing plus 2, plus 3, plus 4, plus 6. Maximum is what? Plus 7. So you know that means automatically you can write chromium Cl2. So that. So lowest oxidation state MnCl2. So MnF4 or MnCl4, that is. Next, oxidation state we know means automatically you can write all those things. Suppose copper is there. So CuCl2, cupric chloride. Next, CuCl, cuprous chloride. It is writing as Cu2Cl2, cuprous. Next, mercurous. So HgCl2, mercuric chloride. So next, Hg2Cl2, mercurous chloride. So mercurous chloride you called as a calomel. So important name. So like that. Suppose silver. Silver is showing only plus 1, AgCl. Gold you are taking plus 3. So AuCl3. That. Next, oxidation state no means every compound we can easily write. Next, oxides. Suppose you take oxides. So oxide FeO, Fe2O3, Cu2O, CuO, Hg2O, HgO, mercurous oxide, mercuric oxide. See, silver means Ag2O. Next, suppose manganese. So manganese means MnO. So Mn3. So Mn2O3, MnO2. Next, MnO3, Mn2O7. So based on oxidation states. See, suppose you want to think about properties means what? It is plus 2. Oxidation state it is plus 7. So plus 2 means what happens? It is a large size. Mn plus 7 means it is a small size. So what is the large size properties? Ep rebel metal. So electropositivity. Next, basic character is more. Here you take electronegativity is more. So acidic character. So middle compounds has amphoteric characters. So that are coming. Next, oxyhalides. So third one. You can take oxyhalides. Suppose the same thing. So manganese is showing plus 6. One example you take. I am adding 2 oxygens. So 2 oxygens means what happens? MnO2. Next remaining is halogens. 2 halogens you take. How many positive charges? Same number of negative charges. So that is the formula. Next, vanadium. So 5. A maximum it is what? Plus 5. Suppose I am taking 2 oxygens. So 1 chlorine. So your formula is what? VO2Cl. Suppose V plus 5. 1 oxygen only I am taking. 3 chlorines. Minus. How many positives? Same number of negatives. So that's why what? VOCl3. So like that is the formulas are coming. Next, another oxy anions or oxycations. So that is the fourth, oxy ions. So oxy ions also forming. So vanadium. So vanadium is which group? Suppose scandium, titanium, vanadium, chromium, manganese. So this is what? Third group, fourth, fifth, sixth, seventh. So maximum. Suppose vanadium you take. Vanadium is a plus 5. I am adding one oxygen. So that means what? VO. Remaining is what? Plus 3. You can write. Vanadium plus 5. Two oxygens you write. So that means what? VO2 plus 1. Next, vanadium plus 5. Three oxygens you take. So then what happens? VO3. Above what? 6 minus. Means 1 minus is extra. Above that. So manganese. Suppose chromium also you take. Chromium is what? Plus 6. Suppose 4 oxygens I am added. 4 oxygen added means what? CrO4. 4 2s are 8. So that is what? Minus 2. So K2CrO4. So like that. Next, suppose chromium plus 6 is there. I am taking 2 oxygens only. 2 oxygens means what happens? So 4 is gone. So chromium CrO2. Remaining is plus 2. So oxyanion, oxycations. Suppose manganese is there. So manganese is what? Plus 7. So I will take 3 oxygens. 3 oxygens means MnO3. 3 to the 6 is over. So you can write plus 1. Suppose more than that, Mn plus 7. 4 oxygens I am taking. So that what happens? 4 to the 8. So MnO4. That is what? Minus 1. 4 to the 8. So like that. So these are forming compounds. In D block elements, we have two important compounds. So one is potassium dichromate, K2Cr2O7. This is. So here the preparations. So preparations of this one. So first you take ore. So that is a chromite ore. So chromite ore, the formula is so FeCr2O4. FeCr2O4. That is a ore direct we are taking. It is treated with base. So base means Na2CO3 or NaOH, whatever it may be, in the presence of air, oxygen compulsory. So we are heated means that become as sodium chromate, Na2CrO4. So this is step 1. Next, step 2. Step 2 means that sodium chromate, Na2CrO4 treated with acidic medium. So you are getting Na2Cr2O7. But actually we want potassium. So that's why that is treated with potassium compounds. Na2Cr2O7 treated with KCl. So you will get K2Cr2O7. So first step is treated with base in the presence of oxygen. So second one you treated with acidic medium. So direct you will get, instead of sodium you can convert into potassium. So that is one preparation. Next, here the important points are what? CrO4 minus 2, Cr2O minus 2. So that structures you can see that. So the important ions are what? CrO4 minus 2. So chromium you take. So 4 oxygens. So 2 are what? Minus 1. Minus 1. Double bond O. Double bond O. So chromium surrounded with 4 sigma bonds. 4 sigma bonds means that is sp3. Structure is tetrahedral. Next Cr2O7, Cr2O7 minus 2. So here also 2 chromiums you take. So here double bond O, next 1O, double bond O, next O minus, O minus. See, chromium is the sixth group, so that's why it is forming maximum 6 bonds. 6 bonds are less than 6 bonds, okay. More than 6 bonds you are written means that is wrong. So here also 1 sigma, second sigma, third sigma, 4 sigma. 4 sigma means what? That is sp3. Structure is tetrahedral. This chromium also 1, 2, 3, 4. That is also sp3 tetrahedral structure. Bond angle is nearer to 109 degrees 28 minutes. So next this properties. So properties is what? It is a strong oxidizing agent. So strong oxidizing agent. So next here the colors also, color combination also in entrance point of view very important. So what are the important compounds? K2Cr2O7, next K2Cr O4. So in basic medium, in the presence of base, so K2Cr2O7 is converted into K2CrO4. Exact opposite in acidic medium. So in acidic medium what happens? Potassium chromate become as that dichromate. So this is yellow color. Potassium chromate is yellow color. This is orange color. So that is where to where which compound is converted and what their colors also, that is important. See K2Cr2O7. So in chemical properties you remember A6. So that means in acidic medium 6 electrons are exchanges. See K2Cr2O7 plus H2SO4. What are the products? So try to write down products means what happens? You take here positives. Potassium is plus. Chromium is what? Plus 6. So it is total is what? Chromium. 4, 7 2s are 14. In that 2 gone. Remaining is what? Plus 12. So 2 chromiums are plus 12. Means 1 chromium is plus 6. How many electrons exchanges? 6. Means what? Chromium become as plus 3. Oxygen is minus 2. Here what? H plus. Here SO4 minus 2. So what is the chemical reaction means? One reactant positives react with another reactant negatives. So potassium SO4, you are getting K2SO4, one is the product. Next chromium sulfate Cr2SO4 taken thrice plus hydrogen and oxygen, you are getting H2O. So these are the main products. Now you can balance 2 potassiums, 2 potassiums, 2 chromiums, 2 chromiums. Next SO4, 3 plus 1, 4 is there. So 4H2SO4. 4 is there means 4 you write down. So 4 oxygens are over. Remaining is 3. So this is the basic equation of K2Cr2O7. So this nascent oxygens are the responsible for the oxidation. So K2Cr2O7 react with it is H2S in acidic medium. What will be the product? So like that the question is asking. So first you write down the basic equation. So what is the basic equation? K2Cr2O7 plus H2SO4 gives rise K2SO4 Cr2SO4 taken thrice plus 4H2O plus 3 nascent oxygens. So now what happens? This is question is given. So H2S is taken, that oxygen. So you are getting H2O plus sulfur. See here, 3 oxygens are coming. Here, 1 oxygen only utilized. So that's why you multiply with 3. So then what happens? 3 oxygens cancelled. So what is that formula? K2Cr2O7 plus H2SO4 plus 3H2S gives rise K2SO4 plus Cr2SO4 taken thrice plus 4 plus 3 7H2O plus 3S. So that is over. Next, suppose this is a theory based or whatever it may be. Now, directly how to write this one? So how to write directly this one means, so here to here, exchanging is how many electrons? 6 electrons. So here to here. So 6 electrons are exchanges. Here to here what? 2 electrons are exchanges. So how you are getting 6 and 2? You multiply with 3. So that means what? So H2S, it is multiplied with 3. So direct your answer is over. So here 3 is coming. This is 6. So like that directly you can do the questions. Whatever the question is given. So first of all you write down the basic equation. Next that oxygens are taken by this one. Suppose we see another example. Suppose you take organic. So in the organic, you take CH3, C double bond OH. Otherwise, you take alcohol only, CH2OH, treated with K2Cr2O7 in acidic medium. So what will be the product? See, alcohol treated with K2Cr2O7, your answer is CH3COOH. So same this question we can take here. See how many oxygens are utilized here. So one oxygen. So remove the hydrogen. Another oxygen O is coming. So that means what? 2 oxygens are required. CH3, CH2OH react with 2 oxygens. Then what happens? CH3, C double bond O, OH plus here 1 H, here 1 H. So that means H2O gone. So now, what is that? Here 3 oxygens are coming, here 2 oxygens. How to balance? This is multiply with 3. This is multiply with 2. So your balance is over. So completely you write down that. Okay, you complete that one equation. So 3 2s are 6. 3 2s are 6. That will cancel and you complete that equation. Next, second important compound, that is KMnO4. So preparation of KMnO4. So ore is a pyrolusite. So pyrolusite MnO2. Same here. First step is what? Treated with base KOH or K2CO3 in the presence of oxygen. So you will get K2MnO4. It is a green color. Next step, acidic medium. Acidic medium you are treated means KMnO4. You are getting purple color. So this is very very important in entrance point of view. KMnO4, KMnO4 and K2MnO4. See, K2MnO4 acidic medium. You will get this. It is a green color. This is a purple color. Next, in basic medium, so KMnO4 become as K2MnO4. So they can ask color and conversion from which medium. Also they are asking question. That one. Next, here also. So this is also what? A strong oxidizing agent, KMnO4 also. but here it is what? A5. So you remember, in acidic medium, 5 electrons are exchanges. So you take KMnO4. So KMnO4 treated with H2SO4. So what will happen? So first of all, whatever the reaction, so what are the positives here? K plus 1. So Mn. So 5 electrons are exchanges. So 4 2s are 8. 8 1 is gone. 7. So in 7, 5 electrons are gone. So remaining 2 electrons. So in acidic medium, manganese is Mn plus 2. Oxygen is minus 2. Here H plus 1. Here SO4 minus 2. So what is the reaction means? One reactant positives are reacting with another compound negatives. So your compound is what? K2SO4 plus MnSO4. Next H2O. So now you balance. So 2 potassiums. So you take 2. 2 Mn. So you take 2. So 2SO4 here 3. 3. Here 3H2. 3. Remaining is what? 4 2s are 8. In 8, 3 oxygens are gone. So 5 oxygens. So this is the basic equation. So based on this basic equation, you can do whatever the oxidizing agents. See, suppose we are taken question sulfur. So KMnO4. KMnO4 treated with sulfur. So in acidic medium. Suppose what happens? They can ask. So suppose basic equation you write down. So sulfur. So taking oxygens. Suppose 3 oxygens it will take. So it become as SO3. Next, outside what? Water also coming. So SO3 is taken water molecules. It become as H2SO4. So now how you can balance this one? See, 5 oxygens are coming. Here 3 oxygens only utilizing. So that's why what? This is multiplied with 3. This is multiplied with 5. Next 5 oxygens, 5 SO3. So this is also multiplied with 5. So now you balance. So that means what? 5 3s are 15. So 5 3s are 15. So 5 SO3, 5 SO3 cancel. So that means what? 3 2s are 6 KMnO4 plus here 3 into 3, 9H2SO4. Here 9H2SO4, here 5H2SO4. So that's why these are cancelled. So 5, here what? 9. So you write what? 4H2SO4 plus 5 sulfur. Next H2O. This side what? 5 water is there. This side what? 9 water is there. So 5 9. Here what? 4 water you will get. 5 yes gives rise 3K2SO4 plus 3 2s 6 MnSO4 plus 4 water. So that is balanced. So like this, whatever the equation is given, you take basic equation and write down that oxygens utilizing and complete the products. Next, some important points in this density. So highest density is what? Iridium is greater than osmium. So highest melting point is tungsten. Lowest melting point is mercury. Next, iron. Iron is available pig iron, cast iron. Next, wrought iron. So wrought is pure. Next, cast. Impure is what? Pig form. So iron combining with carbon, you called as a steel. So that one. Next, iron does not combining with mercury. So it does not forming amalgam. Next, permanent magnet. So permanent magnet means alnico combination. So with iron. Next, matte or matte. So that is a combination of copper sulfide, iron sulfide. It's called as matte, TTE. Next, blister copper. So blister copper means pure copper. That is 98% of copper. So you called as blister copper. Rolled gold. Rolled gold means copper plus aluminum. That is. Next, already we seen calomel. So calomel is what? Hg2Cl2. Next, Nessler's reagent. Nessler's reagent is what? K2HgI4. So next, so you take Ziegler-Natta catalyst. So what is Ziegler-Natta catalyst? AlR3, TiCl3 or TiCl4. So titanium chloride. Next, Wilkinson catalyst. So Wilkinson catalyst, triphenyl phosphine. So triphenyl phosphine rhodium chloride. So that is a Wilkinson. Next, Bayer's. So Bayer's reagent, that is what? Cold diluted alkaline means basic, KMnO4. So cold diluted alkaline KMnO4. Next, Tollens. So Tollens is what? Ammonical silver nitrate, ammonium hydroxide, little amount NaOH, silver nitrate. So AgNO3 solution. Next, Fehling's. So Fehling's means that is a copper sulfate. Copper sulfate, next, sodium potassium tartarate. Next here, Benedict's is there. So Benedict's reagent means copper sulfate only, but sodium citrate. So citric acid we are using in the Benedict's. Next, Fenton's reagent. Fenton's reagent means FeSO4, iron sulfate with hydrogen peroxide. Next, Itard. So Itard reagent, chromyl chloride, CrO2Cl2. Next, Lucas reagent. Lucas means HCl plus N-hydrous zinc chloride. We can take. Next, oil of vitriol. So the famous one, oil of vitriol. So oil of vitriol, which one you called as H2SO4. So in this blue vitriol, green vitriol, white vitriol. So blue means copper sulfate 5H2O. So green is what? Iron sulfate, FeSO4 7H2. So white vitriol, that is zinc sulfate. So some important compounds. Next, wonder metal is a titanium. Wonder metal is a titanium. So highly hard, lightweight. So weight is low, hard is more. So that is wonder. Next, mish metal. This is also famous in entrance. So mish metal means 95% lanthanides plus iron 5%. So next, that nickel is purified in Mond's process by using what? Carbon monoxide. That is. So iron is extracted in what? Blast furnace. So what is that combination? We can add lico. So that is 1 is to 4 is to 8. So lico 148 you can write. This is limestone. Limestone is 1 is to. Next, coke. Coke is 4 is to ore. So that. So like this, any other important compounds you can take. So next we will discuss about F block. So F block elements, what are that? Lanthanides. So lanthanides are what? Sapropus, Ugat Badiho. Next, Erratiulu, lutetium. See, it is what? 58 to 71. Suppose you write electronic configuration means so gadolinium. It is what? 4F off filled. Europium also 4F7. Next, here it is what? 4F14. Here also 4F14. So these half filled 2 are there, fully filled 2 are there. Next, here cerium and gadolinium. Here what? 5D1. 5D1. So lutetium also 5D1. So electronic configuration is very important in this. Next, actinides. So that is Tapavunpuva, thorium, protactinium, uranium, Tapavunpuva, plutonium, americium, curium, berkelium, californium, einsteinium, fermium, mendeleenium, nobelium, lawrencium. So that is what? 92, 103 elements. So here, see curium and lawrencium. So curium is what? Here 5F7. Americium also 5F7. So lawrencium is what? 5F14. So front also, this is also 5F14. That one. Next, where is the 60? So 6D1, 6D1, 6D1. Here also 6D1, here 6D1. So that electronic configuration they can ask means you can see this. Next, general electronic configuration. So general electronic configuration of lanthanides means 4F1 to 14, 5 to 1, 6S2 is the general electronic configuration. What about actinides? So instead of 4F, 5F you take. So 5F 1 to 14, 6D 0 to 1, 7S2. So where is the position? So position of this means, so these are present in where? So sixth period. Sixth period, third group. Third group or Roman letter third B group. Location. This is seventh period. Seventh period, third, otherwise third B group. So general oxidation state. General oxidation state, these are showing +3. Some elements are showing +2. Some elements are showing up to +4. Next here, general oxidation state of lanthanides. These are showing +2, +3, +4, +5, +6, +7. So more positive oxidation states are shown in this. So these are generally called as rare earth elements. Rare earth elements. Both lanthanides and actinides you called as rare earth elements. After uranium elements are called as transuranic. Transuranic elements are man-made elements. So transuranic or man-made elements. See, the actinides and lanthanides properties are very close. So that's why these are separated. So by using chromatography technique. So chromatography, by using chromatography, the separation. So separation of lanthanides and actinides. So this is chromatography is what? Physical adsorption phenomena. So that we can take. Next, who is readily forming complex compounds? So lanthanides are forming less complex compounds. But actinides are readily forming more complex compounds due